We begin by uploading a sample image from our local environment. This image for which we want to generate synthetic data. Next, we enter number of images that we would like to generate. For this demonstration, we will generate 10 images with rust damage. Since generating 10 images will take approximately 2 minutes, I will fast forward to when the images are ready. Now that the images have been generated, let's look at a few. As you can see, we have obtained fairly decent synthetic images with rust damage. Next, we will repeat the same process to generate synthetic images with frost damage. Click on Generate Synthetic Data and wait for synthetic images with frost damage to be created. It is worth noting that adding additional classes for different types of damages is simply a matter of editing the prompt that goes into the Amazon Titan model. You can find out how to do this by following the link provided in the resource section. Now that the images are generated, we will check out few. As you can see, we have very decent set of images. Next, we will upload the images to S3. Now that the images have been uploaded to the path shown, we will use them to train the Amazon Recognition custom labels model for damage detection. To do this, copy the S3 location of our synthetic dataset and go to the AWS console page. Look for the Amazon Recognition service, and once on the landing page, select Use Custom Labels, then Projects, and then Create Project. Here, you will enter the project name and click Create Project. Now that the project is created, to begin, click on Create Dataset and choose the option to import images from an S3 bucket. Next, enter the S3 location that you previously copied. Make sure to tick the checkbox labeled Automatically Assign Image Level Labels to images based on the folder names, since our application has uploaded the images in required folder structure. We also have already configured our S3 bucket with necessary policy. So click on Create Dataset and wait for the dataset to be created. After creating the dataset, we can view the different images that will be used to train the model, and then we click on Train Model. We will now select the project for which we will be training the model. In this case, it will be the project name that we had entered before, and click Train Model. Since this is going to take some time, I will fast forward to when the model is trained. Now that the training is complete, we need to deploy the model to start using it. To do this, click on the model's name and then go to the Use Model tab. Next, click Start and wait for the model to become ready for use. I will fast forward the video to when the model is ready. Now that our model is ready to use, we will copy the model ARN, that is Amazon resource name, for our code. This code will utilize the Train Custom Labels model to detect damage. We will run the cells one by one. For the first image we are testing, you can see that it has rust on it. We will wait for the output from the recognition model. This recognition model's output confirms that we see the classified label is rust damage with a confidence score of approximately 81.6%. Next, let's look at a sample with frost damage. The valve in the image looks completely frozen with snow piled up on it, and the recognition output also agrees. It classified the image as having frost damage with 93% confidence.